I remember taking a photo of one of the subjects. He came into the lab, showed his quads, and it was kind of wild visually how much larger the higher volume, lower intensity leg looked.
What a trip.
Yeah, and it's like, what was that? I think anyone that's spent more than a few years in the gym and had training partners and been part of like a gym community, people lifting, can acknowledge that not everyone's responding the same way.
Sure.
Over time.
Sure.
And I think part of that is how they train.
Cody Haun, PhD. Welcome to the show.
Good to be here, man. Thank you for having me.
It's a huge honor. I knew you when you were an undergraduate at the same institution, ETSU, that I was a PhD student at. And I met you and we chatted a few times in the gym and things like that. And then later I was told you were in the master's program. And then later you went on to get a PhD and so on and so forth. And I followed your career, and just impressive is the only thing I have to say. The continuous amount of insight that you put out is like, I want to know what Cody has to say. And because of that, we got a dirigible, a blimp, a Zeppelin to pick you up. 2 weeks later, it dropped you off at our house. I hope the caviar was to your liking.
It's good.
Now it was good. It was fun. Mm-hmm. It was sufficient. Mm-hmm. Real quick, we already know you have a PhD in, what is exactly your PhD in?
Well, technically the PhD is in kinesiology, sure. But I concentrated in exercise physiology.
Exercise physiology.
And I worked in the molecular and applied science laboratory, managed and supervised and led by the one and only Dr. Michael Roberts.
Yes, of Auburn.
That's right, at Auburn University. Yep.
Now, are you an Auburn football fan?
Sure. Yeah.
Ooh, careful. Sure is not a sufficiently dedicated answer.
If you answered the question, someone's going to be upset, right?
That's true.
Yeah, I am. I'm originally from Tennessee, so go Vols, right?
Okay. Good. Good street cred there.
Yeah, man.
You have lifted weights for a really long time. How long have you been lifting for?
Man, I started, I would say, resistance training.
Yes.
Under my father's tutelage with some ankle weights and calisthenics. Cool. Like he felt that was like the way to do things. And we did some bench pressing and curls when I was like 10.
Wow.
Yeah. But like really getting into it, like when I took my first scoop of creatine monohydrate.
Bye natty status.
Yep. That was at 14. So 14. Freshman in high school, sure. That's when I really started getting into it.
That's when a lot of people start lifting.
Yeah.
Because you're like a kid before then.
And insecure.
Yeah. That part never left me.
Yeah. Same.
Is there? Okay, excellent. Yeah. We're on the same page. Yeah. All right. Science time?
Sure, man.
Science time. I have questions.
Hey, I'm excited.
Excellent. All right. So first question for you is sarcoplasmic hypertrophy. Sarcoplasmic hypertrophy sounds fancy and like a really cool science word. Mm-hmm. And if you're on a first date with some girl that went to NYU or something and she seems kind of like she thinks you're stupid, you can just say that and she's like, oh my God, really? Like, tell me more.
Smart, yeah.
So smart. So there are, I think, 2 types of hypertrophy maybe, and one of them is sarcoplasmic. What is the sarcoplasm? What is sarcoplasmic hypertrophy, and what's the other kind, and why do we care?
Yeah, I've kind of been taking the title of the sarcoplasmic hypertrophy guy, which was not the intention of that research, was to answer a specific question.
Very long Instagram handle if you're going to put your hat on that one.
Yeah, we can work on that. We can workshop it, Sarcoplasm Man or something to shorten it, Sarco Man, I don't know. But yeah, I think we should probably start with a lot of words that are poorly defined, right? Sure. And I think hypertrophy in and of itself, or hypertrophy, as some people would say.
The hypertrophy.
Right.
Something you win for big muscles.
Right. I got really interested in that. Like, what is actually increasing in the muscle cell as it grows?
Yes.
And that was, so like the review article we published during my PhD at Auburn, it's in Frontiers in Physiology. It really meant to help answer that question. It sounds silly. It sounds like, should we know what that is?
It's all just muscle, right?
Right. But it turns out, there wasn't a lot of good, I would say, intentional research on measuring more of the cellular morphology or the structures and proteins and organelles inside of the cell. Mm-hmm. There was a good amount of research, and we're talking about 5 years ago when we published that, and so I really wanted to survey the literature and see what do we know about what things change inside of the cells when they grow in response to resistance exercise. And the deeper that I got into the literature, there wasn't a lot of research on it.
A lot of speculation.
Yeah, a lot of speculation. And you would, see, increases in fiber cross-sectional area, right? Or increases in lean body mass from a DEXA scan.
Yeah, very big picture.
Yeah. Or do an ultrasound image, and if the thickness of the muscle increases, that's hypertrophy. And so what struck me from some of the training studies that we were doing at Auburn in the MASL, Brooks Mobley, he did a training study, and I was kind of like his right-hand man there. For that study, it was 2 semesters long, and we took muscle biopsies. There were almost 100 subjects.
Holy crap.
Yeah.
For folks tuning in, that's an unusual number of subjects for an exercise science study. Very high. You'd be lucky if you get 20.
Yeah, right. And, analyzing that data, I did a lot of the image analysis and the agreement between methods. So if you have a DEXA scan, lean body mass, or just appendicular lean mass. So just looking at the mass of the legs or the arms, and you see that increase. Well, we would think that if you look at an ultrasound, that should increase alongside it, right? The thickness measurement. Or if we look at fiber cross-sectional area in the same muscle, well, that should increase alongside. They should all agree, and they didn't very well. And so that kind of sent me down this analysis of okay, well, why? But then moreover, what if we see a fiber? And when I say cross-sectional area, so let me back up a little bit. If we take a muscle biopsy,
which is ripping out a part of a muscle.
I brought a biopsy needle with me to do this on camera.
Scott, the video guy's ready.
Okay. All right, Scott. Come on out, man. No lidocaine. And so, we actually take muscle tissue out of the quadricep. And then for cross-sectional area, through a series of steps, we ultimately mount a very thin slice of muscle fibers onto a microscope slide, and we stain it, and we're able to visualize it using immunofluorescence microscopy. So you can see the membranes, you can see the myonuclei, you can see the muscle fibers in cross-section.
Right. Yeah. So it's a muscle cell, is this long thing, also called a muscle fiber. You cut it and you look at it from the long way down, and then how big it is how much hypertrophy has maybe occurred. If it was smaller, then it was bigger. But then what about the contents? Do they all grow at the same rate, or did we just not know at that point?
You're on it. So it's okay, in cross-section, we see the cells get bigger. Mm-hmm. What went up?
Right. What are the options there? We have the myofibril itself, which is kind of like the actin myosin stuff that pulls. That's what does the work. But then we also have some mitochondria in there. If it's an endurance athlete's slower twitch muscle fiber cell, it's tons of mitochondria, not a lot of contractile apparatus. And then there's also the whole thing that all that sits in is called the sarcoplasm, like the soup of the cell. If anyone's ever seen an animal cell in a cross section, you got ribosomes in there, you got mitochondria in there, you got a nucleus somewhere. If it's a muscle cell, you have contractile material, but all that soup that fluid, everything, it's inside the cell. That's the sarcoplasm, correct? And so like if you grow a muscle cell, but the sarcoplasm increases, but you don't increase any of the contractile material, the actin myosin stuff, you're not going to get any stronger, probably, because there's no more ability to contract. But if you increase, maybe there's a way of training where if you increase the size of the cell a little bit, but way more contractile material and not a lot of the soupy stuff goes up, it'll look the same to someone else who's like, those two guys are equally as jacked. But if one guy has more myofibrillar hypertrophy versus sarcoplasmic hypertrophy, the sarcoplasmic hypertrophy is like what people used to say, and I am asking this question immediately after, is like back in the 80s, they surmised that bodybuilders who had big muscles, but they weren't as strong as powerlifters for the muscle size they had, people would say, okay, the powerlifters have more myofibrils in the same size cell or even smaller, but the bodybuilders have maybe the same size myofibrils, a few less. They have tons of sarcoplasm. That soupy part is just pushing the cell out so big that they have these big, more or less useless muscles. Is that all bullshit, or is there some truth to that, or what the hell is really going on?
Right. Well, I'm still trying to figure that out.
Okay. What do we know more about that?
I think, and there's what we saw in our lab, and there's other researchers that are like interrogating these questions. So sarcoplasmic hypertrophy, just to like clearly define it, and you were, I think, largely
the
accurate
fifth grade
there.
version.
If we take that cross section, right, we have this fiber, which you said it was a kind of like a cylindrical structure, which is what we used to think. And this is only in the last like 3 years that we've learned this. And Brian Glancy did some of this research using much more sophisticated microscopy work, showing it's more like a mesh. Myofibrils are more like a mesh, like a lattice network, instead of just like these cylindrical structures.
Okay.
That said, the myofibrillar sort of network, or cylinders, if you will, that run along the length of the fiber, there are the sarcomeres in there, the contractile proteins, that's where we're generating force. That probably occupies about 85% in general of that spatial environment.
Of the average muscle cell.
On average.
Average skeletal muscle cell.
Yes,
Okay.
yes. All right. And so then the other 15%, what is that? And so probably about 10% of it is the sarcoplasm, which is this kind of fluid medium, this aqueous media that everything kind of moves through and is suspended in, right? And you've got enzymes and ribosomes and, ions and all that stuff that's kind of floating around.
Soup-like.
Yeah. And so, and then, the sarcolemma, the actual membrane of the muscle fiber.
Yes.
Right.
The outer covering of the muscle cell.
And then you've got your myonuclei. And one thing that makes muscle particularly interesting is that it's multinucleated. There are multiple nuclei that run along the length of the muscle fiber. And so sarcoplasmic hypertrophy, if that spatial environment and the structures within it are preserved in proportion as the cell grows, that would be conventional hypertrophy, right?
You get it all. More of everything.
Yeah.
That's how I order at the restaurant.
In proportion to how you started.
Yes.
So sarcoplasmic hypertrophy, therefore, would be a disproportionate increase in the sarcoplasm as the cell grows.
Yes.
Relative to its starting state, you see?
Yes. That's kind of like you have two different size options for soup at the restaurant, but they both have the same amount of meat. One just has more broth. And you're kind of like, are you guys ripping me off?
Your analogies are so great, man.
Right? Like I miss maybe a little bit of that. But if by great you mean stupid and childish, I agree wholeheartedly.
Oh, that's a good analogy.
Right. But so you don't get any more of that meat. And I think that for bodybuilders, they don't really give a shit. Someone's like, it's all sarcoplasm. They're like, oh yeah, watch this. Hey, whoa.
Right.
But with powerlifters,
if you've got some sarcoplasmic hypertrophy going on, I'd take some of that, buddy.
Exactly. It's just literally steroid oil. But anything practical for people to take away from the sarcoplasmic versus myofibrillar. Some people would say train for low reps, you get more myofibrillar stuff. You'll have a denser muscle, it'll be stronger for how big it is. Other people would say, look, all of these are probably transient changes, and that over the long term, whether you train for low reps or high reps, you're going to get the same degree of jackness and roughly the same degree of cellular contents anyway? What's your take on that?
Well, I think prematurely, and I'll mention Dr. Chris Vann again, because after the sarcoplasmic hypertrophy experiments and the reviews that I did at Auburn with Dr. Roberts, Chris went on to help address more of these questions, particularly loading, like heavier loads versus lighter loads,
yes.
right? Kind of lower volume, higher intensity, higher volume, lower intensity within subject design.
Oh,
so awesome. One leg, which is really, it strengthens the study. And so it seemed, and again, using sophisticated methods, proteomics, it seemed that the higher intensity loading paradigm promoted more of an increase in myofibrillar protein abundance.
Wow.
Than the lighter loading paradigm. Now, it wasn't a night and day difference, but I remember taking a photo of one of the subjects that was like, he came into the lab, like showed his quads, and it was kind of wild visually how much larger the higher volume, lower intensity leg looked.
What a trip.
Yeah. And so, Dr. Roberts would call that like the eye test, you know, and it's like, what was that, and so there's inter-individual differences, I think, that exist in how people will respond.
Sure.
And I think there's a lot of contention around how that's like statistically analyzed, and it's like fair enough. But I think anyone that's spent more than a few years in the gym and had training partners and been part of like a gym community, people lifting, can acknowledge that not everyone's responding the same way over time.
Sure.
And I think part of that is how they train.
Yeah.
Right? What are they doing? Now, practical application. I think that it's fair to hypothesize that if you lift with heavier loads relative to your capacity.
So that's a 5 to 10 versus like 20 to 30 or something.
Yeah. That's probably we'll say, less ambiguous signal to your cell of what you want it to do. Make more of the mechanotransduction machinery, the contractile machinery.
Yes.
Right? Because that's really what we're doing when we're training. We're telling our nuclei to transcribe genes.
Yes.
Which genes are we telling them to transcribe?
Right.
What are the signals? Right? And I think those signals are specific. And I think that if you're loading heavier, a lot more tension experienced in compressive forces in the fibers, that it would make sense that the contractile apparatus, the proteins that make up the, thick and thin filaments and that connect that myofibrillar sort of mesh to the membrane, because that's interesting, right? There's proteins that actually connect it, right? It would make sense you would make more of those, but then if you train more, again, in that more glycolytic system. So
15,
we're talking
20, 25 reps.
Yeah, somewhere in there. Probably see more of the response that I saw like in my dissertation work, right? More glycolytic enzymes, more of those sarcoplasmic reticulum proteins.
And more of all proteins, of course. You still get growth in the contractile proteins, but fractionally less than you would expect if you did lots of sets of 5 to 10, for example.
Yeah.
Does this, in your mind, give you some insight into very hypothetical periodization model where you train for high volumes with higher reps for a while, and then you have a lot of architecture built and the cell has expanded, and then maybe if you train that same muscle with heavier loads, that's a 5 to 10, you're going to fill in the contractile machinery, backfilling? Is that...
And this is where, like, if... depending on the strength of my answer and how confident I am in it, like especially in the scientific community, like a lot of the people who are researching this would get really worked up because it's like an extrapolation of like limited evidence to the, and so like carefully, I would say with much more work to do and a lot of respect to other labs who found different things than us.
Sure.
We could be wrong.
Sure, of course.
Maybe we did something wrong. I don't think so. I think that we were very careful.
Yeah.
And I've seek the truth the whole time.
Sure,
like, I don't have a dog in the race other than like I want to know the truth.
Other than that 1897 dog.
Other than that one, and RIP, thank you for donating tissue to science.
Yes.
But I think, man, I mean, and what I actually tend to do with people that I work with on their programming that are trying to maximize muscle growth, I feel comfortable organizing training into periods of higher volume.
Sure.
Or sprinkling it in a phase, or emphasizing it rather during a certain phase primarily, and then shifting into more of a heavier load for a similar amount of time, or at least maybe like half of the time that so if you did 3 months of like sets of, we'll say 6 to 12 reps, and then you had, I really like the, I don't know how far we want to get into like programming, but sort of like, I think Brett Contreras has called this sort of idea the rule of thirds, where it's just like it is, you train within, a lower rep scheme for some of your work, and then an intermediate rep scheme, and then kind of that higher rep work, right? You're kind of checking all those boxes within a session chronically. So within the session, it might look something like that, right? Where you do for a squat, for example, let's, do a set of 3 to 5. And then for perhaps, if we're talking about the quads, a rear foot elevated squat or a leg extension even, in that intermediate rep range. And then perhaps you finish with like some light lunges where you just do like 30. So we're kind of surfing the curve there, right? Of like that repetition continuum and using different loads within those different rep ranges
to check all the boxes of the different ways in which muscle grows.
And that's like what it could look like within a session, but how you might periodize it is something like that, right? Where it's just like maybe 1 month or 4 to 6 weeks, we really lean into that 3 to 8. I really don't like putting like a fixed number on this stuff.
Heavier.
Yeah, heavier. And then perhaps the next month we go more 8 to 12, and then you see what I'm saying?
Sure.
And then we do more. It's not like we never do these other things like vertical and horizontal integration, some people would call this, across the annual plan. But you see what I mean? You might do it that way.
Sure.
And I think the variation is also something that's useful for people to keep people engaged.
Of course.
Yeah.
You never it's unlikely you're ever going to train only for low reps or only for high reps if you want your best gains, because just for psychological variation, it gets boring to do the same thing over time.
Right.
Yeah. All right. Next topic. We could talk about that for like the next, several years. Yeah. Muscle fiber type transitions with exercise training.
Okay.
So I am not a big fan of 2A, 2X, 1, whatever the fuck. I consider that nomenclature wildly outdated and on principle excessively simplistic. I like to, and there's lots of evidence confirming this, see fiber type as largely spectral in nature. There's a spectrum of faster twitch fibers all the way to slower twitch fibers and everything in between. Can you tell us the story about how when someone just starts training, what happens to their fiber types? And also, are there any things or ways of training that we can employ that will change our fiber type at least a little bit into the direction of the kind that grow bigger? Because from what I understand, when you first start training, because your muscles are very untrained, hilariously, they're more faster twitch than slower twitch, just chilling. And so as you train for muscle growth, your muscles get bigger, but it seems that they behave more and more like slower twitch muscle fibers. And the slower twitch fibers also don't grow as much, though they do grow, as the faster twitch fibers. So we have a bit of a conundrum where as we train for weeks and weeks and months, we're getting bigger, but our proneness to getting even bigger starts to decline a little bit because our fiber types are shifting over to be slower twitch, and those aren't the kind that grow the most. The faster twitch ones do. That does explain, at least in part, the phenomenon of newbie gains pretty well, because like if you're all damn near pure fast twitch, you're going to grow a fuckload. But as you get more and more slower twitch, you're like an endurance runner kind of, and they don't hardly grow from shit. They just kind of like do work, and I don't know where that all goes. But then people have the question of, okay, now that I've been training for months or years, is there any way for me to get the fibers to shift back to faster twitch without losing a ton of them so that I can get another bump of growth? That's the conventional question and story I'm familiar with. What do you have to say about the matter? Does any of that make sense to you? Or is it all like, nah, that all just ends up in the wash?
Well, and you just had Daniel Plotkin here, who's the first author on the muscle fiber type, shifting perspectives paper. And I think that was a really good piece of work there. I mean, and he really summarized the literature well.
We didn't talk at all about that, by the way.
Okay.
Yep. So you're going to have to talk
Well,
instead.
I want to definitely give credit where it's due.
Sure,
right?
sure.
Like he could probably explain this much better. But
Okay.
I mean, what you said, man, is, some themes, right? It's like, okay, someone's untrained and they have relatively small muscle fibers. Those muscle fibers, let's start with this, right? So for a number of years, I mean, really, Dr. Andy Galpin, I think, helped to really clarify some of this using single fiber isolation techniques and looking within individual muscle fibers.
Which is important to get really deeply at the heart of the matter.
Yeah. And so there's just been different methods used to classify. We like to dichotomize things, right? We like to make things like it's black or it's white, or it's
Fast
right
or
or
slow,
it's wrong, or it's yes or it's no. And a lot, like most things are kind of on a continuum, right? Like a grayscale. And so like fiber types for a long time where it was like type 2, type 1, maybe there's subtypes like type 2A, type 2X. But the methods used, I think, had some serious limitations.
Yeah.
Right? And it's just like, okay, we're taking a tiny chunk of muscle out of this. By the way, that is a notable limitation in the exercise science literature. Like, I did a lot of biopsies, really cool technique. We can learn a lot. It's been solid in a lot of ways. However, dude, most of that literature is from this muscle right here. Like 150 milligrams of samples.
Small part of that muscle right there.
It's just like, and we have some other biopsy data, but like most of it's right here. It's just like, well, is this
representative of the whole human body?
Right.
Maybe not.
Right. And so, okay. But if we just look at a lot of the research on that guy, we used to use that sort of classification system. And I think just to kind of boil this down to sort of maybe practical applications, the best way to fiber type, I think, is based upon the actual myosin heavy chain isoform.
Yeah, the molecular, right? What the hell is going on? Yeah,
that's the...
How fast does the contraction occur? Yeah. That's why they're called fast and slow.
Right, and specifically, it's an ATPase. Like it hydrolyzes ATP.
Yep.
And we get energy from that, and then it grabs onto the thin filament and pulls the structure of the sarcomere together. That's contraction, right? But the rate of that ATP hydrolysis differs based upon the specific protein isoform. So you've got myosin heavy chain 2A, myosin heavy chain 2X, and then myosin heavy chain 1. And there's some other kinds that you'll find in other animals. But the primary myosin heavy chain isoform within that fiber is probably the most appropriate way to classify it as more fast twitch or slow twitch.
Sure.
Faster,
primary,
slower.
But not the only one.
Right.
Okay.
Right. Exactly. And that's been one of the findings, right? Is like, well, along the length or perhaps this mesh network, right? You can have different myosin heavy chain proteins within the same muscle fiber.
Sure.
And
so the pure distinctions are gone because of that.
Yeah. Right.
Right. It's like this is a fucking terrible analogy. I'm sure shit can get canceled for. But it's like in the modern United States, like NFL, you talk to someone and be like, all right, so do you do like black athletes or Samoans, or do you have white guys on your team? You're like, it's all of them. Like, So to call a team a black team or a white team or a Samoan team in the pro league, it doesn't make any sense.
Right.
You could talk about fractions. Not that that tells you much, but you know what I mean? It's just, it's just a totally, there may be 3 races of dominant football player, but on any given team, there's a bunch of different ones. So if you wanted to see, well, are Samoans really the best at football? You could see, like, when you have more Samoans on your team, do you do better statistically? But then you have to start collecting data from all the teams, and you can't fucking collect data from all the muscle fibers in a human, can you? Stupid IRB committees won't just let us invite people in and just completely digest all the muscles off of their body.
It's like harvest all of the muscle.
Come on, we got priorities. We got, tell you what, man, we've got China beating us at the Olympics, and we're not even ready to start camps where people go to where their bodies are digested for Scott. You with me?
Yeah, we need Scott to lure them in like he's luring me in and like to the vampire cave thing.
We're on it, man. We're one step ahead.
Yeah.
All right. So different isoforms in the same muscle, in the same cell, which means all cells are relatively on a spectrum of having more of some of those and fewer than others.
Yeah. And that's, go ahead. Sorry.
What is that? What about change over time? So that's how you start.
Yeah. Well, and I would just add like some other important differences that tend to be associated with a slower twitch or faster twitch fiber. And to be clear on the myosin heavy chain, the 2A and 2X, they literally hydrolyze ATP faster. That's why we can twitch faster. There's probably some differences in the sarcoplasmic reticulum too, but it probably takes up a little more space in type 2 fibers for that calcium flux as far as facilitating faster twitch.
Yes.
But that's not super clear. More mitochondria in the slower twitch fibers.
Which is a big deal for at least 2 reasons and many more. One is if you have more mitochondria in your muscle fiber, your ability to have more endurance to supply those contractile structures with continued energy, continued ATP is just way higher. But on the other hand, it's a trade-off because there's now more mitochondria taking up space and you can't stuff as much contractile material in there. So it's a trade-off of, do you want better endurance or do you want more ability to produce force rapidly? Which is why you do not see humans who sprint the marathon. Sprinters are faster. Marathoners are slower but have more endurance. It literally boils down, at least in part, to like, there's only so much space in a cell of a given size. Do you want more mitochondria or do you want more contractile material? Are you guys working on getting like some pocket dimensions in muscle cells or some shit so we can have it all? Explain Forrest Gump. How does that work?
I don't know. I aspire to be like him.
In what way?
I would like to run like that, and the beard and like the kind of mullet situation
cool. that
Tom Hanks had going on. Yeah. Chocolate's tasty as well.
Chocolate's nice. Scott, do you think Tom Hanks grew out his hair for that, or was that a prosthetic beard?
I'm sure that was all wigs.
Scott, I don't like it when you pop my fantasy of Hollywood being genuine. Another question really quick, is timely as of this recording. Scott, everyone's having fun voluntarily in P. Diddy's mansion, right?
Oh, geez.
Perhaps not. If you believe such things as indictments and reams of evidence and anyway. All right. So there's a lot of different stuff going on in a given muscle cell to make it faster or slower twitch. Everyone genetically starts off with certain proportions of faster and slower twitch muscles in any given muscle. What about changes over time with training and detraining? Tell us what that's all about.
Yeah. And I think we go back to that principle of specificity, right? Where it's just like, from a real high level, man, if you train more like an endurance athlete, so we're doing more lower force repetitive contractions for extended periods of time, well, then the muscle cell is generally going to move in that direction, right? More mitochondria, more capillaries that supply blood, better perfusion, better oxygen delivery, more myoglobin perhaps to transport that oxygen to the mitochondria. And that's kind of, and more myosin heavy chain isoform ones.
Yes.
Like that's kind of what we see in a limited number of studies.
Sure.
And I think Daniel did a nice job of like really pointing out that hey, there's some themes here, but like we still have more research to do.
Sure.
But you kind of move in that direction. If you train in a more explosive way, high force, high power output, you seem to see in some of that research that we see more of the properties that we described before. Sure. More of the faster myosin heavy chain isoforms. So I think it's probably not very useful to like try to optimize your training program to have more myosin heavy chain 2As. If you have a performance outcome,
yeah,
right.
Performance athletes, look, you got to be a sprinter. You're going to do low reps. You're going to be a 400-meter runner. Maybe you can do some higher reps. You're going to be an endurance athlete. Your reps are on the track and no longer in the weight room because no one does 1,000 squats in a row. However, for muscle size, for getting jacked, is training to try to get the fibers to not transition too much to the slower twitch better? Is there any way that higher reps versus lower reps give you more long-term growth? Because here's a story I've heard. I have no fucking idea if it's true.
Okay.
If you train for sets of 25 to 30 reps, it's kind of the upper end of the hypertrophy rep range. We already know that compared to training for sets of 5 to 10, within several weeks or months of time, the macro structure of hypertrophy is the same, roughly. Like you get just as jacked training with 5 to 10 as 25 to 30. We know that. Schoenfeld and colleagues showed that a long time ago. It's been replicated a crap ton since. The idea that like sets of 5 to 10 are just categorically better for muscle size within the span of several months has been just discarded as, tentatively highly unlikely to be true. However, what I've heard some people say is, look, if you train with sets of 5 to 10, your fibers don't transition as much to slower twitch variants. The ones we know don't grow as well. If you train with sets of 25 to 30, they transition more. I don't know how much more, but more. We could surmise it's more. So then does that mean that after months of equal jackedness from sets of 5 to 10 versus sets of 25 to 30, that the 5 to 10 people would actually start to outgrow the people that insisted on training in 25 to 30 rep range, because those guys basically made themselves into slower twitch functioning muscles, whereas the faster twitch functioning muscle sets of 5 to 10, they're still more fast twitch and now significantly more faster twitch than the 25 to 30 group, let's say after 8 months of training or 2 years of training. And now maybe they gain muscle at a higher rate because they didn't screw up their fiber type, so to speak. All temporary transitions, of course. Is there anything to that at all? Or is that like way too premature? Or that's just not how it works at all? Or just the ultimate, just giant question mark?
Well, you mentioned, and what a researcher, right? Dr. Brad Schoenfeld has done a lot of wonderful original research.
Oh yeah, sure.
And yeah, I mean, it seems like a theme, right, at this point, where if we're training two groups, 20 to 30 reps per set, 5 to 10, and usually that's something like 80%, 30%, one rep max. But we have, I think, a good amount of evidence now looking at comparing lower and higher loads with similar volumes. If the volumes are similar, you see similar growth as it's commonly measured.
Right. And in the time courses as it's commonly
That's
measured.
right. And I mean, there's not a lot, we don't have, again, that cellular morphology, I'm curious about that, right? Like if you took that out 2 years, maybe the whole muscle volume would be similar. I just don't think that the intracellular milieu, we'll say, would be the same.
Right. That's an interesting claim.
Yeah. And I think it's beyond the myosin heavy chains, right?
It's all other kind of enzymes and everything. That's an interesting idea. So maybe it again lends credence to trying to experiment over time with different rep ranges for yourself. So that like, look, if you just like, some people go on preference alone. Like, dude, I like sets of 5 to 10. Fuck 25 to 30 right in its disgusting butthole. Scott, isn't that funny that I tried to censor that part? Like, sir, you said the F word, and then you couldn't say the A word. YouTube will come on. There's like a certain number of swear words you're allowed to have per unit time, and I wouldn't know. Yeah, I would, unfortunately. Chronically exceed. So, and if you tell those people, look, like, you ought to try some sets of 25 to 30, they'll throw the Schoenfeld research in your face, and rightly so. They'll say it doesn't matter. It doesn't matter in the short, medium term, weeks and months, but maybe it matters in the long term. And, well, how could you tell? Well, if you've been doing sets of 25 to 30 for months and months and months, or sets of 5 to 10, let's say for a given muscle group, months and months and months, see if you can flip the script and go to a totally different rep range as the predominant rep range. Mm-hmm. And maybe you'll have some new growth. Mm-hmm. Is there at least a speculative reason to try that sort of thing because of the different types of cell structures we're building? I think so. Yeah.
I mean, and like, you've been training for what, Mike, over 20 years, probably longer.
25
like,
years.
Think about that, right? For doing 25 to 30 reps for every exercise for a year.
I mean, yeah, it's intense.
Right? And then
nobody really does that.
Right?
Although guys really do train 5 to 10 for years and never go up any higher.
And I mean, but in that example, it's just like, well, then shift to like sets of 5. Yeah. That's just like a wake up call. Like, oh, I forgot what heavy feels like.
Yes.
Right?
Yes.
And so some variety there in loading makes a lot of sense. And that can be applied at the per session level. That can be applied within the microcycle. It could be applied within the meso or in phases.
Yes. So let's chart out how that would look. Intra-session, it would be like you hit up, it could be done on the same exercise. To keep it simple, I will just do that. You do leg presses for sets of 8, for 3 sets of 8, and then you do 2 down sets for sets of 20, 2 sets of 20. You hit sort of both big check marks, higher reps and lower reps. Mm-hmm. Within the week, you could do Monday squats for sets of 6 to 7, and then Thursday hack squats for sets of 15 to 20. That's within the week. Over the course of, multiple mesocycles, you could have like a 4 to 6 week phase using the RP Hypertrophy app. Buy now, link in the description. Where are all these links anyway? I'm convinced there's no such thing as a video description. I've never clicked into one. You would do maybe a few months of mostly sets of 5 to 10, and then maybe a few sets of higher reps for the same muscle. But then you would do a few months after of mostly sets of, and this sounds painful, but 15 to 25, and get away from the heavy stuff. It has another benefit of like, it is unequivocally a good idea for joint integrity to occasionally do a mesocycle of lighter weights. Mm-hmm. And for psychological integrity and not having to quit the fucking sport, you can't all do just sets of 20 all the goddamn time. Can you imagine that was like, I would love for some research to come out that's like, actually sets of 30 on the leg press and the squat are categorically superior for gains. How many bodybuilders would be like, I'm out of this sport, man. I don't need that shit in my life. You know what I'm saying?
Yeah. I mean, and I think that's where like it's, be careful.
Don't be careful. The worst that can happen is literally hundreds of millions of people that watch our channel will be completely misinformed and will ruin their lives.
All right, great. So I think, man, this is where like one of the passions of mine is bridging science to practice. I love molecular biology and like really getting into the weeds on this stuff. But insofar as it helps inform what people really do and how it can be helpful for them.
Sure, because otherwise why study all this stuff?
And
if it's like, not getting me jacked, I don't want to fucking read about it.
Well, and it's like, I think a lot of researchers, would benefit from like actually trying the training programs that are, at least being contemplated to put someone through.
Yes.
And I wouldn't trade the experience, man, that I had as a personal trainer and as a strength and conditioning coach for like 5 years for anything, man. I mean, that was super valuable to inform more of the physiological research. And like, the sets of 20 to 30, like perpetually, it's draining, A, but then B, like, I just don't think that you're going to get the maximum growth effect if that's someone's goal. And really, if I had to like gravitate on this continuum, which seems to be, we'll say like 5 to 30, right?
Sure, that's a fun heuristic.
I would rather see people gravitate over to the lower half in general.
Yeah, in general.
And partly going back to fiber types, I think one of the reasons that we see in the research that type 2 fibers tend to display notably larger increases
in muscle size.
Okay. From a training study. I mean, that's one of the more consistent themes. Why, right? It's like, I think one reason is in people particularly who are untrained, they don't use them a lot. They're not activating them much.
Makes a ton of sense, dude. Holy mind blown. So basically, activation is fiber by fiber. The whole fiber contracts when the whole fiber contracts, but there could be multiple parts of your muscle that are just not doing shit, while other muscle cells or the muscle fibers are doing all the work. An example is when you're walking around the zoo with your family, you're not like, this analogy.
Sounds fun.
Yeah. After that incident in 2015, I've never been allowed to a few zoos.
Gorillas.
You're not allowed to climb into the exhibits and harass the animals. This is what they told me. I didn't consider it harassment. Attempting to hug a fuzzy animal I thought was just connecting with nature. I was on a lot of psychedelics. I mean, like, I didn't even see my own hands anymore in front of me. But so you're walking around the zoo. You're not using your fastest fiber types, your fastest fibers, because that would be hopping around the zoo. Right. Like, those are for jumping and sprinting and lifting heavy fucking shit. And so what you're saying is you've got all this lifetime as a person who just sits on the couch of at least getting up and going to the fridge and the bathroom and ostensibly work, perhaps. And then your slower fibers, which are the only ones activated when you get up off the couch and go get some from the fridge, they're always kind of training. And so they don't get noob gains, basically. Whereas faster fibers, they kind of like are left the fuck alone. And so they're just ready to get growing whenever they're called upon. That's certainly some fraction of the explanation.
Yeah.
Damn. That's interesting. That's really cool. And once you get through your noob gains, though, then what happens? Well, I guess the story's kind of similar still, because if you only train your fastest twitch fibers when you're doing inclined bench press, and you never train them reaching for your toothbrush, but you're always training your slower fibers reaching for your toothbrush.
Now you're talking.
Same conservation of the same principle, even for trained athletes. Okay, last question on this fiber type topic.
Okay.
What can I take to make me faster twitch? Is there a drug or a supplement or a diet or a sleep protocol? Is there some kind of red light therapy I can zap my testicles with that'll make me more fast twitch?
I'm not aware, man. I'm not aware of any. I mean, I think, perhaps some of the anabolic androgenic steroids may promote we'll say an expression of genes, more of the type 2 variety.
Interesting.
Maybe. But
okay. I've seen some research that speculates they actually promote the type 1 more. So very disappointed when I read that.
Well, and it's like, what a limited body of research. And it's unfortunate, right? Because like, hey, those compounds are scheduled, okay, but it's like there's a lot of really interesting health and performance implications of these compounds that are all just kind of lumped together in one category.
Yes.
Without getting too far into that. That might be something, but like, I think training specifically for the desired outcome, right, is probably the best thing that you could do to move the fibers in their orientation, like in the direction that you want, faster or slower.
Does deloading or taking an active rest boost the fiber type into the faster twitch variety? And does that make it such that you get more growth than you would otherwise? I think so, for two reasons. In study after study after study, how often you deload, even if you deload a lot, as long as you get back to hard training, you get all of your gains back and then some. And so to me, what I find compelling about that is if you have a situation where you train hard for 3 weeks and then take an easy week, 3 weeks, easy week, and there have been a few studies that did similar comparisons versus one in which you train 7 weeks and take the 8th as an easy week, you're training more total hard sessions over the course of months in that second example, waiting for a long time until you deload. If you deload relatively often, you spend less total time over, let's say, 6 months training. But in study after study after study, it's the same fucking growth. And so it's like, if you can get free growth by training less, that to me seems like a fucking dope thing. And maybe the fiber transitions are a part of that, where when you don't train hard for a week, your fibers transition a little bit more into faster twitch. They're more growth sensitive. And yeah, they'll detransition after a few weeks anyway, but that's when you cut off the training again. And so when you're training for 3 weeks on and an easy week, 3 weeks on an easy week, you're retransitioning more often. And thus the average fiber type is faster twitch through those 6 months. And thus it grows more, but you're training less. So it grows less and ends up evening out. So if you want to just get the same growth, but train a lot more, I'm not exactly sure why you want to do that, then you just don't deload super often. And you are cooking the muscles all the time, but they're so goddamn not growth prone anymore by that point towards the end of every mesocycle that, let's say, the last week or two of that 7th and 8th week, oh, you're training all right, but you're so desensitized to hypertrophy that it might not be adding in as big of a way. Anything for you on that seems off or seems like it's on something?
So I think there's kind of two topics here. It's like fiber type transition with deloading, and then potential resensitization, which is a very interesting topic. There is some evidence, right, with deloading or a taper, that we can see more of those fast twitch fiber isoforms, in the tissues.
Coming back.
So, okay. Not a lot of evidence though, right, for that, but I'm not, I guess, do we want to optimize for that? Like, I think it has more of an implication for athletes.
For sure.
Right?
But for just getting jacked, does that return to the faster fiber explain part of that? It's so easy to get your gains back, because if you're faster fiber dominant again after, let's say, 2 weeks of not training, isn't that why you get, in part, why you get big ass noob regrowth gains in the first week of coming back? Because you're now a faster fiber?
I don't know. I don't think so. I think you look at the muscle memory literature, right? And muscle, it doesn't have a brain. So I don't love the name, but
I hate the term muscle memory. Yeah. Even I use it sometimes. I hate while I'm using it.
But there does seem to be some, there is evidence to support this, in some sense, molecular memory.
Sure.
Of previous stimuli. And for example, Adam Sharples, I believe he's in Norway, has some interesting work on this. And there's some interesting work from, let's see, his lab's done some cool stuff on this with epigenetics.
It's always the Scandinavians that do the best muscle work, God damn it.
But the other thing, Mike, is just myonuclei. So this is mixed, but we were talking about satellite cells earlier. With weeks of training, let's just say there are some studies that show an increase in myonuclear content.
Sure.
All right. And that seems to be mediated by that satellite cell donation. Yes. Okay. Those myonuclei, there's a term you can, go to PubMed and type it in, like myonuclear permanence. And this is interesting with, again, anabolic androgenic steroids, is like we also tend to see this long-lasting myonuclear increase that perhaps as long as years, at least as long as a few months. With
perhaps forever.
Maybe.
Well, until you get old and
maybe
that old, everything's irrelevant.
But it's like myonuclear resilience feels a little better, just with the data that we have. But that seems to be one of the primary reasons that you can regain lost muscle and strength after a period of unloading or deloading or detraining.
Sure.
I mean, there's evidence as long as like, I mean, a recent study I reviewed was like 16 weeks of no training after like a 10-week initial training block. And hey, muscle fiber size decreased, strength decreased as we would suspect. But then the myonuclear increases that happened from that first 2.5 months were retained for like 4 months.
It's like having better genetics.
Kinda.
Yeah.
Yeah, again, the myonuclear domain theory, right?
Yes.
So.
Next topic.
Okay.
Exactly tangenting off better genetics. What do we know about high and low responders to muscle growth programs and why they are different? And just for folks sort of not clued in, we used to call them non-responders, and there are actually non-responders. We know that because we've measured it numerous times. There are people, and this is wacky as fuck. Every time I tell it, I can't believe I'm telling it, but I've seen the data myself. There are people who will undergo 16 weeks of supervised resistance training, fucking hard, and they're untrained. They've never trained before. And upon every method of analysis, have grown no muscle at all. Can you imagine having that be your client in personal training and telling them, look, I got good news and bad news? And then there are people that will grow 3, 4, 5 times more than the average person grows in the same time. And you're like, what the fuck is happening to your body? And everything in between, which is why we don't say non-responders versus responders anymore, but low and high responders to training. Cody, why do we have any good reasons, anything to pin down? What is it inside my body that either hates me or loves me so much that it either lets me get ultra jacked or makes getting jacked a giant pain in the ass?
Yeah, this is still a big interest of mine, and we published like 5 studies at Auburn in like 3 years on this topic.
Summarize for us. What are you finding?
Yeah, so we already touched on some of the physiology here, right? So we hit on satellite cells. That seems to be one.
So having lots of satellite cells around your muscle to start with, genetics, means you have a ton of support coming in to help grow as soon as shit gets hairy, and you're going to just get more jacked fast. All right, that's number one. What else we got?
That's one. I think we touched on capillaries. We touched on mitochondria, right? We touched on ribosomes. So some of those things. So just kind of running the list here.
Yeah.
It seems that at baseline, so if we took a chunk of muscle and we did, histological examination and we looked for capillary density. So those are the vessels that supply blood to the muscle. And what's in blood that would be growth promoting? Well,
everything.
Right? So it's like if we can perfuse the tissue better, we would expect for that to complement growth.
If that's a limiting factor.
Yeah.
Sure.
So like that seems to be one that
no way.
People who,
So people who are faster, like who respond better to training, get more jacked from the same amount of training, they have higher capillary densities?
There's some research supporting that.
Oh, wow.
Mm-hmm. Yeah.
If I bear down enough, does that help me grow capillaries?
You could try. I mean,
I'll try.
Worth a shot.
Yeah.
Yeah. Little harm. I think, yeah. So that's one. And that's interesting from a periodization standpoint, I think.
Yeah, because then if you've been experiencing higher volume training that we know for a fact increases capillarization, are you potentiating more muscle growth later because now the bloodstream is not as limiting of a factor anymore?
Or one might even consider, here it comes, cardio.
Shut up. Scott, turn off the cameras, unmic this guy. We're not here for nonsense like that. What the hell? And we do have evidence that people that are in generally better overall cardiovascular shape, I do not mean the difference between marathon runner and regular person. I mean the difference between someone who is in insanely terrible couch potato shape versus someone who moves around a bit more. If you take identical twins, the twin that moves around a bit more probably going to have better results from a muscle gain program because gee whiz, their body's just better at everything at that point, including supplying the raw materials for muscle growth. Ribosomes, you said, were a thing. These are literally the molecular machines that build proteins. So genetics for ribosomes are a big deal because your nucleus could be like, hey, build muscle. And your ribosomes are like, there's like 3 of us here.
Right.
The fuck? It's what's the good analogy here? You hire someone to build you a house. One guy shows up with his team of 3 dudes. Another guy shows up with 20 dudes. Who's building you a bigger house?
That's a good analogy. Yeah, that's right. Yeah, and that's one of the more consistent findings. That's less controversial. This is actually, believe it or not, a controversial topic. I think
only because people get butthurt about it, or because there's mixed evidence?
I think the way that you analyze the data, I've found people like have been really upset with us over our analysis of the data, as far as how we statistically analyze it, and in some sense, clustering subjects instead of treating it more like a continuum, like taking a group of 30 people and putting a subset in low response and a subset in high extreme response, and then comparing groups as opposed to treating it like a continuous variable. And it's like, well, fair enough. And I think we should do more research and do a different analysis. And at this point, like I'm a big fan of open science.
Sure.
Open science, transparency.
Sure.
From beginning to end.
And shit like that.
Yeah, all that. Like, here's what we did. Here are modifications that were made. Here's all of the data.
Yes.
That you can.
Raw data is dope because you can de-identify all of it. It's not like anyone's calling anyone on their cell phone at home.
I think,
like, hey, I heard you were a low responder. Click. You're like, oh, I should never enroll in that stupid
And dude,
study.
now, I mean, we really like, you know, we're talking about exercise science, which is like, obviously I'm passionate about it. But then when you get into things like the climate and, you know, curing cancer.
Yeah.
And things like that. Not
slightly more high stakes.
Yeah, and like, man, I think we want to share the methods and the modifications, and
might as well do that for lower stakes shit.
Yeah, and it's becoming more popular. Like my wife, actually, Courtney, she's it's TOPS training. NASA is supporting it, and it's transformation to open science, and it's free. It's free training. It's really basically education on like how to do
science that's open and accessible.
And I mean, I think, man, the last handful of studies, original work that we've done, we've just shared the raw data.
That's awesome.
That said, that aside, with like how it's, I think people from a practical standpoint can acknowledge, I hope, that people are different and people respond differently to the same stimulus.
Yes. And it's for real reasons, some of which you don't have control over, like ribosomal density or whatever.
Right.
Cody, anything else? Sorry, please.
Yeah. That said, one of the things that I don't think is as controversial as far as what's influencing the responsiveness for muscle growth is ribosomal content increases. More of these molecular machines that translate messenger RNA into proteins. If we get more of those, we can translate more mRNAs, we can make more proteins, right? And here's what's cool. You threw out the genetics term a few times, and it's like, it turns out, and there's Dr. Roberts actually, they're working on some of this right now at Auburn, and our DNA copy number repeats. So the genes, the segments of our DNA that actually encode the information to make ribosomes, we can perhaps have different copy numbers. So let's say that you have 20 and I have 5. And we do the same training program. Well, theoretically, because you have more of these copy number variants that encode the information for the ribosomes, right? You can make more ribosomes.
With the same transcription throughput, I just make 4 times more ribosomes than you do. That's cheating, bro. We gotta start testing people for ribosomal genetics.
I mean, genetics, dude. I mean,
genetics matter. They matter like crazy.
Yeah.
You have to be nuts not to admit that.
Well, and it's one thing, the source code is one thing, right? I mentioned epigenetics earlier. We didn't get into that with muscle memory, the myonuclear piece. And then there also seems to be this really interesting methylation process of our DNA that seems to be retained in some way. That when you train a certain way and then you come back to it after a detraining period, the genes are the same, but the expression patterns are different. And why is that? And it seems to be, you have your DNA around a histone, and that whole complex, the DNA protein complex, is like the chromatin, but it's got a kind of, it's like a, you're better at analogies, yarn around like a spool. So we need to open it up so that those transcription factors have access.
Yes.
Right? And that process, those epigenetic modifications, there's like acetylation and lactylation from lactate, which is something we might get into with metabolite accumulation and some of the reasons why that satellite cell signal is activated. But there's some kind of interaction with DNA and lactate that seems to affect the structure.
How accessible the DNA is to copying it and making it do all the things that it does.
Yeah.
Do you have one more genetically confirmed or physiologically confirmed difference between high and low responders for us before we catch the next topic?
Oh man, there's so many. But I mean, we hit some of the big ones, right? The satellite cells, the capillary density, the ribosomes.
What else we got? A couple more.
I mean, we
don't have to explain any of them.
And again, people like to, and hey, I mean, again, have a look at the data, like analyze it however you think is most appropriate. But in my dissertation,
0.00001% of the people listening will do that.
Okay, fair enough. But it's like it seemed that the individuals who had more type 2 fibers at baseline that were trained in my dissertation, it seemed like they displayed a greater increase in cross-sectional area.
Sure.
And so perhaps that genetic predisposition to, just have more myosin heavy chain 2As or 2Xs at baseline is another, moderator of the response.
Yeah.
Those are some of the big ones, man.
Sure.
But there's more. But those are
reasons why you're small. Physiology. All right. Couple more questions because we got a few really compelling questions.
Okay?
I'm doing. Are you good?
I'm having a great time.
I'm having a mediocre time.
Yeah, fair enough.
My range of emotion ends top end at mediocre. It doesn't go any higher than that.
I need to change that, buddy. Get out of the Black Forest and away from the vampire.
He's my coworker. He's the reason we have a YouTube.
And he's like, actually taking the blood, and that's why maybe your
100%,
energy. Okay.
Not enough blood. Yeah. All right. This is going to get fun. We'll come back to some of the muscle stuff in a second.
Okay.
For the lactate, etc.
Okay.
But I'm curious about cold plunges.
Oh, geez.
And sauna exposure.
Yeah.
The stuff on recovery, the stuff on health, I'm decently competent in. I've explained it on our channel before.
Mm-hmm.
What I'm not clued in on, and you are, is what is the effect of the sauna and heat exposure on muscle growth? Because cold exposure, we already know, fucks that shit up. Maybe I'm wrong, but cold exposure, not great.
Pretty clear for like hypertrophy, man, at this point. Like
especially after training.
Right. Proximal to the resistance training session, it just doesn't look good.
Yeah. So do not cold plunge after you weight train at the same gym or whatever.
If you want to, grow muscle
and get stronger. Are you training anyway? Right, exactly. You list every benefit of resistance training. Unless you're resistance training for your soul only. What about the sauna, bro? What about heat?
Yeah, it's an interesting. Well, first off, I'm surprised by the lack of evidence. There's barely any evidence.
So not a ton of people are doing the studies on if we put people in saunas after training versus not, how much more jacked or less jacked they get.
Yeah. So I guess the first disclaimer is we don't have good longitudinal, well-powered, good research on it.
What about from what we do have? What can we surmise?
And I think this is important where it's let's look at established phenomena. And one, it's particularly in Finland.
They love the saunas.
They do. And when you compare sauna users, more than 4 times a week seems to be 3 or 4 times a week, 20 minutes ish, hot though, 170,
uncomfortable.
Yeah, to maybe as high as 190.
What the fuck? All right,
it's hot. Those individuals to individuals who don't use the sauna in terms of all-cause mortality risk, I mean, it's 40-50% different.
I don't like that agglomeration of studies in the inference at all because it's very difficult to parse health practices aside. Mm-hmm. You could just be screening for conscientiousness at that point. We already know conscientious people live much longer because they give a shit about everything. Mm-hmm. And in some cultures, the sauna attendance is a thing that people do when they're very health conscious. And so
is it really,
is it really the sauna
is
that's
it the
doing
sauna
it?
or
Right.
is it,
100%.
Sure.
So like, people who, when they're in the second grade, have all their colored pencils lined up by color on their desk orderly, make more money when they grow up. But is it because of the colored pencils? No, it's just because they were that person that organized systems around
colored
them.
pencils.
They're nice. I hated them and I can never organize shit. That's why I'm dirt poor. But as a scientifically minded person, I have to say the research is very interesting, and it could very well be that something about the sauna enhances longevity. But we also know that things that enhance longevity, like caloric restriction and like endurance training, are dog shit for muscle growth. So do we have to be suspicious now that the sauna is bad for muscle growth on mechanistic grounds? Then again, I saw a recent one study that illustrated that exposure to heat did trigger some hypertrophic mechanisms. What do you make of that?
We're working with like I say, that was the first disclosure, right? Is like already in a limited body of evidence, there's limitations of, any like all-cause mortality research. There's so many potential confounders. Sure. I think there's some really well-controlled things that we've learned though, like smoking is not going to be health promoting.
Yeah, directly.
The all-cause mortality risk data on that, I feel pretty confident.
Yeah.
Not so much with the sauna.
Right.
Okay. Let's and just to be really clear, if you compare the research on cold plunging after a resistance training session, it's consistent, right? From acute measures of muscle protein synthesis to like using MRI to look at muscle volume after weeks of doing it. We're talking like 40, 50 degree water for like as little as 10 minutes after a session can really knock that hypertrophy response down. Down
substantially.
Yes.
Not out, but down.
Down. Maybe 30%, 20-30%.
Oh, fuck, really? Right? That's a lot. Scott, Did you hear that shit? Did you give up 30% of your growth because you dipped your balls in a fucking icicle? Fuck that.
That's interesting, right? Okay, and so it's like, well, why? And I think that's informative when we start thinking about the sauna.
Okay, please continue.
Because one reason at least, and this has been measured, there's some research out of Leon Roberts, Australia, where they've looked at like temperature, skin temperature changes, perfusion, arterial flow. There's some vasoconstriction there, right? Like when we're really cold, the vascular response is to shunt flow to other regions of the body to direct it to keep our core temperature regulated.
Yes, your body thinks it's dying of the cold, and so it pulls everything into your heart, liver, kidneys, etc. And your fingers and your biceps, to be honest, are just like whatever.
Yeah, and some people think that that's one of the reasons why it's health promoting. We'll just leave that there for a second. But okay, so if it's blood flow mediated, again, go back to capillary densities with response variation for hypertrophy. So if we're blunting blood flow to the muscle right after the training session, and that seems to really decrease the muscle protein synthetic response, the growth response over the course of weeks. Well, what if we enhanced it?
Mm-hmm.
Right? What if we increased blood flow?
By putting you into the sauna.
Yeah. Right? Because it's the opposite, vasodilation. And I think then you get into like, well, what is it? Brownian motion, right? Heat. It's movement. It's movement of stuff.
All the molecules and everything. Yeah.
And it's like, well, are we perhaps encouraging the interaction of ribosomes and some of the molecular machines that are involved in instigating the initiation, of translation of those mRNAs?
Sure.
From heat.
It does make some assumptions, though, I will say. Your body's pretty good at keeping your temperature. Well, I guess the core temperature stays about the same.
Yeah, the core temperature.
But the peripheral temperature, even in large groups of muscles, can change pretty decently.
Yeah.
Okay. So, never mind. You and I together refuted my stupid idea I had in my head, where I was trying to be a bit cynical and saying, like, look, like, your muscles are still not fucking ice cubes when you're done training. And like, how much more heat can we heat them up to by getting into a sauna? I will say the huge benefit of a sauna. Now I'm thinking about this. I'm thinking maybe we'll, Scott, we got to install a sauna right in the gym because bro, with our gym lighting and the fucking getting out of the sauna, bro, if you get out of the sauna with like a fucking chest and tricep pump, you got veins
right
every fucking, it's
I know,
freaky.
If for no other reason.
Just pictures, bro.
Right? Exactly, man. So yeah, I think those are some reasons. But then there's an interesting class of proteins, man. And there's at least one study, and to be clear, there's no study that I'm aware of that shows that if you do the sauna after you resistance train for a period of weeks, that you grow more muscle. So
a lot of folks watch this channel. People, get on it. You want some money, hit up RP. Just kidding. Please don't do that. It's not my problem, really. I don't do customer service. No, but seriously, it would be fascinating to see. And it's not a hard study to do, to be honest. One group like is told to just chill in the sauna, and one group is told to chill in the sauna, except they never fucking turn it on. Or 2 different temperature conditions. That way you obviate any psychological stuff.
Right. Yeah. So we need to do that.
Yeah.
Study.
What about the what is it? Heat shock proteins? Yeah. The shock part really makes it shocking.
I know, right?
The proteins are like, ah!
Yeah. It never like ceases to amaze me, some of the names of like molecules. They're so funny. There's one called Son of Sevenless.
That's so sweet.
I know.
People who discover shit just have carte blanche to name it. If I discovered a molecule, instantly dildo molecule. Next. Like, Mike, it's not even shaped like a dildo. I'm like, you just don't have any imagination. Anything's a dildo if you try hard enough. Yeah. Scott says it's true.
You guys, man. Oh, man. Okay.
But we promise your microphone that you're close to right now has never, ever been used for that function this several past hours for sure.
Good to know. Yeah, dude. So those things seem to be like molecular chaperones. They seem to help proteins go where they're supposed to go. Now, why?
God only knows.
I mean, it's a little, I would say, misunderstood, but that seems to be their role.
Yeah.
We have this synthesized protein, and heat shock proteins seem to kind of usher it to the cellular compartment that it's supposed to go to. And so that's interesting.
Very.
And we have evidence that people who use the sauna, like if you take tissue, they seem to have more of those heat shock proteins. So like, I think there's at least a couple good reasons why the sauna could be an adjuvant to help with promoting muscle growth alongside potential, and I use this word carefully, detoxification. I know. I use it very carefully.
Cue hipsters.
I know. But there is evidence that in sweat, right, you find things that are probably not great for us to be present in our bodies. Now, of course, toxic load makes a difference, sure. Right? Exposure and
but
so on. But
clearance can be a cool thing.
Right. And you're chilling. It's not like we're talking about...
That's so important.
Right?
So as long as you're psychologically comfortable in a sauna, what my personal recommendation, if you want to try this out at home, let me know if you think this is decent. If you have access to a sauna, like, a lot of people have sauna access in their gym. After you finish a hard session, get your carb, protein, fluid, and electrolyte shake. Bring it in with you. Sip on your shake. And chill in there for 10, 20, maybe minutes or something like that. And really make sure you're in a posture that's relaxed. And if you just hate being exposed to heat, probably not good for the stress response. But if you can just chill, maybe get some headphones going or something like that, it might be worth a try to see if it has some kind of beneficial effects, because the kind of peripheral reasoning is starting to get interesting. Mm-hmm. What do you think?
Yeah. Well, and there's some recovery data like on it where in general, subjective recovery scores, soreness, those sorts of things, sense of, perceived recovery seems to just be better if you use the sauna.
Interesting.
And like when you compare the potential negative effects from cold plunging from the body of literature on that, yes, to the potential negative effects of sauna, it's kind of polarized almost.
Polarized opposite. My only reservation was twofold. One, no direct data, and don't put your faith into this just yet. I'm not installing a sauna in my gym just yet, but it was 3 or 4 well-controlled studies and making more jacked. I'm putting a fucking sauna in there ASAP. My only reservation is your body absolutely adores comfort and homeostasis. And after massive homeostatic disruption that is training, I have good reason to believe that the next thing you want to do is be as comfortable as possible. And maybe accessions into both low heat, high cold, and high heat environments are maybe both different versions of the wrong answer. It's kind of like asking a person like, do you want to spend the next 12 hours in total fucking silence with no one talks to you or is even around? Or do you want people yelling at you? Like, can I get just people like coffee shop ambiance? Or like, no. But that's what most people like best. That's my only reservation. I will say, like, if heat exposure and saunas turn out to magnify the growth response, Scott, we're turning the gym up to fucking 90.
You already do, man.
Shut up.
And I mean, that's, you know, even like doing a few minutes before a session, sometimes I like to do that, just to warm up, right?
That's a great warm up. Right? It accomplishes the warming for you. I will say, for folks who get carried away by my 90-degree gym comment, don't do that. There is compelling reason not to train in a high heat environment. Your performance will go down like crazy. Jared Feather and I travel around the world doing seminars and stuff a little bit. And him and I have had some sessions in Australia and in Thailand where we both look at each other and we're like, we have 30 minutes to crush quads until we can't do anything anymore, because there's just not that many fluids in the world to put back into your body. Just excessively high heat does not work from a performance perspective. But if you can do the high heat just before for warming up, or the high heat just after for that extra boost for growth, maybe, then there's something to it. Another thing really quick, what do you think about this? The internal temperature of your working muscles while you train is way higher than baseline. Is that part of the hypertrophic signaling cascade? My biceps get hotter when I train them. Is that part of what makes them grow? Or do we just not know enough? Because heat shock proteins, I don't know.
Yeah, I mean, and I would say that's one of the, and Dr. Quindry, who's at the University of Montana, I remember he had done some work on this, at least taught us in advanced exercise physiology too at Auburn. I remember we had a whole section on this. And my understanding is that exercise in general tends to increase the abundance of heat shock proteins. And like if we had a group of 100 sedentary individuals and 100 people who, you know, had exercised for years, and we pulled muscle tissue and we just looked at how many heat shock proteins were present.
Even at baseline.
Yeah, just cross-sectional analysis on that. Yeah.
Wow. That's trippy. All right, so TLDR, give the sauna a look, but the cold plunge, you got to drake that shit because it's not going to help you out. It's going to make you less. You gave some skepticism and maybe like just a counterpoint to that with the cold plunging. Perhaps, like, and I think this is a deeper conversation too on like, not everything that we want to do that makes us comfortable is good for us. Yeah.
Right? Sometimes the right thing is the hard thing.
Oh, sure. That's training. Yeah.
Right. Yeah. Overload, right? Yeah. It's literally more challenging than before.
Yes.
Okay. So with cold plunging, man, if nothing else, I think perhaps, and people that I talk to that I present this evidence to, it'll be like, I would not recommend for you to do this after your session for these reasons.
Right.
Because I want to help you like maximize your progress. They like the psychological benefit. They like being able to control their breathing and calm themselves in a really uncomfortable environment.
That's what sets a 20 on leg presser for.
Fair enough.
That's one hell of an uncomfortable environment, by the way.
Yeah. It's like, yeah, maybe.
But I hear you. You
know what I mean? But other than that, dude, I personally find the evidence, not people's opinion, the evidence underwhelming for cold exposure.
On almost any kind of upside.
I mean, maybe you get some more brown fat activity. That's
nice. In the grand scheme, I'm not sure what that means. But.
Yeah, I'm open-minded. I just don't see a lot of benefit, that especially some of the hot takes that people have about like fat loss. Like you're going to lose a lot of fat if you do it. It's just like, where's the evidence?
Where are the calories going?
Yeah.
The RP Hypertrophy app has dozens of pre-made workout templates to help you build a plan faster than any other training software allows. But you can customize each plan exactly to your needs by prioritizing and deprioritizing any muscles you like to train, choosing the exact exercises you'd like to use, and customizing the volumes you employ at every single step of the process. If you're looking to bring up lagging muscle groups, look no further than the RP Hypertrophy app. Click on the link in the description of this video to get started. Question. Does lactate and other metabolites that are associated with the burn from higher reps or getting really close to failure or taking very short rest breaks, is there a mechanism by which they cause some amount of muscle growth? Because you get two looks. Some people are like, yep, it's metabolites, it's cell swelling, it's also muscle tension, mostly tension. You get another look from people that's like, it's just tension and they just don't want to have any more of it. Cell swelling aside, I'm quite swollen sitting here just embracing this manhood in front of me. What?
Wow.
Huh?
Thanks.
That was said. You can't say that kind of thing to female guests, mostly because you're misgendering them. But what do you think about metabolites and muscle growth?
Yeah, so I have to give credit to Dr. Daniel Lawson. We published a review article on this, and really thorough. Like there's a lot of pretty much every study we could find that speaks to this, and the resistance training studies in humans that have actually measured lactate, we think we found them. The ones that had like an outcome variable of interest. So there's a lot in there, but I mean, according to our review of the literature, there's enough evidence for me to kind of like you said with the sauna. Like, I don't know for sure, but there's enough here that's intriguing. Mm-hmm. Like when you take simple experiment overall, now the actual protein analysis and that is sophisticated, but there's cells in a dish, cell culture, myoblasts.
Okay. Muscle
cells.
Cells, yeah.
Cells that can, eventually become a muscle fiber.
Sure.
So, okay, we have this solution that has things in there to keep the cells from dying, we'll say, right? And so then we add lactate at a concentration that would mimic what our blood lactate might be.
During hard exercise.
So some of the highest lactates that we have measured from resistance training in the blood, the amount in the muscle is going to be much higher, right? But in the blood is probably 10 to 20 millimoles. Okay. So if we use that concentration and we put that lactate in this petri dish and we incubate the cells for a period of hours or days. And there's a petri dish that doesn't have any lactate present. There's at least like 4 studies, and really the other ones little different designs. And they fed mice lactate. They injected lactate.
I've seen the injection study. I didn't know they fed them lactate. What the fuck does lactate taste like? Acidic.
I don't know. I'm curious. But I mean, in those studies, man, incubated. And then they've done like pulsatile exposures to kind of mimic what it would be like from like in a week's time. Because like one day for a mouse is like a month for a human.
Yes.
Right. And so if we have these intermittent periods of exposure to lactate, the thought was kind of mimicking what you would get if you're training periodically, right? Mm-hmm. Okay. So both of those examples, like incubation over hours or days or pulsatile, you see, generally speaking, larger growth responses, more upregulation of molecules involved in really the mTOR pathway. Mm-hmm. So that's the mammalian target of rapamycin. It's kind of this anabolic complex of proteins that it's involved with initiating the translation of RNA into proteins, protein synthesis. We want more of those proteins to grow the cell, right?
From what I understand, mTOR is one of the critical core pathways of muscle growth in animals and humans. And so like, that's really decent fucking basic evidence, huh?
Right? No, handful.
handful's nice though.
It is nice,
especially with well-controlled animal models. Like that starts to build an interesting picture.
Well, of the like 10, right, half of them in vitro, so culture, and then the other involved an actual, rodent. And those are a little more mixed, but they were kind of odd, the study designs and like translating it to humans.
Sure.
And there's just not, I don't know. Well, take it from here. Like, what do we want to get into with this for practical application? Because
are there any human studies trying to tease apart the mechanisms of muscle growth that you find compelling enough to be like, yeah, there's something here for metabolites? I know that there are many metabolites, and lactate is not the only one, and some of them have been kind of correlated to muscle growth before. But the metabolite hypothesis in general, let me put it another way. Are you aware of any research that completely refutes the metabolite hypothesis?
I wouldn't say it completely refutes it. And that's a really, I think, good frame for this, right? Where it's like, there's a difference between a study showing that something results in a worse outcome versus no difference.
Sure.
And okay, if we take 10 studies and half of them show no difference between, let's say, treatment A or B, in this case, lactate or no lactate, and the other half show a positive effect. Half of them show a positive effect. The other half show no harm. It's no worse.
Sure.
So with a small body of literature, generally speaking, I gravitate to that, right? It's like, well, and that's kind of how I see the lactate story right now.
Yeah.
And if you want to zoom in just a little bit and we can come back out of the matrix, one of the things that really, and Dan found this pathway that I didn't know existed before we did the review that was really interesting, that I think as of today seems to explain this. At least if there is a lactate-mediated anabolic signaling process, this one, right as of now, seems to make the most sense to me. So we produce lactate as a consequence of the glycolytic pathway. Think back to one of our previous topics on with high-volume training, we see more glycolytic enzymes.
Yes.
Well, with more glycolytic enzymes, more breakdown of stored glycogen and glucose coming into the cell to get energy. We make more of those in response to training, but we also form more lactate.
Sure.
Yeah. If we're engaging that pathway, right? And so, okay, lactate seems to behave in, the lactate shuttle.
Yep.
Right. Cell-to-cell lactate shuttle. So lactate can be transported out and go to an adjacent fiber, and that fiber can take it up and actually use it for energy. It can convert to pyruvate and go through the citric acid cycle. Cool. Lactate also seems to bind to this receptor. It's a G protein coupled receptor, which is the most common receptor on our cells, right? There's all sorts of them. This one's called GPR81, and lactate seems to bind to it and instigate a signaling pathway that eventually seems to increase the activity of the mTOR complex.
Yeah. Pathway or candidate pathway that's been demonstrated as, I just call it powerful evidence, but I would call it a real eye opener. Like,
Right.
Because people have been saying observationally for years that, the burn makes a difference. Getting closer to failure, higher density of training, that maybe there's something there. And now that we're finding that when you present lactate to both animals and cell cultures, it causes a growth response.
Right.
And in addition, we have at least a little bit of evidence that there is a candidate pathway that links the presentation of lactate to the activation of the core muscle growth protein complex in humans and animals. To me, that doesn't quite say metabolites for sure grow muscle, but it shows me that if you're saying it's only tension and don't worry about the burn, you're probably not doing something you would be real confident putting money on. It's probably good to be like, I think metabolites might matter, and we might find even more reasons why they matter later. Would you think that's decent?
Yeah, it kind of gets at causality, right? Like necessary, sufficient, or contributory.
Sure.
And I can see it being contributory.
Sufficient is nonsense. There's no such thing as sufficient muscle growth. Until I have muscle tumors on my face, I'm not stopping. Necessary is, I would say, kind of a red herring, because no one's ever claimed that necessary to get a burn. Everyone knows even sets of 1 repeated with enough frequency are going to cause robust hypertrophy. The tension hypothesis is not up for debate here. It's not metabolites versus tension, and it never was. But it's like, you know, if you can get some tension presented, you will with resistance training. But if you can do some higher rep sets and push it close to failure, is there another mechanism called the metabolite mechanism that starts to contribute a little bit more to growth? And is that worth just knowing that it exists offers you some options? So for example, if you're like, man, like heavy fucking weight's the way to go because tension is all that matters, you're going to get some kind of injury and not be able to go heavy. And you're going to be like, well, fuck it, I'm just taking time off. But if you know the metabolite hypothesis is real and it actually works, and then it's the metabolite model instead of hypothesis, then all of a sudden occlusion training, which sequesters metabolites, lets you produce a lot without a lot of force, becomes like a real tenable option. And we already know occlusion training works really well in the short term. But maybe if we can pin a mechanism to it, we can start to understand like, wow, the burn really does matter. I'll put to you the way it matters to me most. I'll tell you this, man, and I'm a fucking huge science nerd, and so are you. This is what we do. If I feel the fucking gnarly burn on something like squats or leg presses, hack squats, some shit you just don't want to do anymore, but I know there's convincing mechanistic linking of the thing that burns you, various byproducts, including lactate and its sort of acidic counterpart,
hydrogen ions,
etc.
Yeah.
If there is convincing data that the stuff you're making that makes your muscles burn also grows you, it changes the psychology of those last few reps, because now pain means growth, and now I want more. Instead of being like, oh, I've already beat my reps from last week, better turn it in. I kind of get, real lizard-eyed and go, oh boy.
And that's fun.
It is. It is. Well, so if you knew for a fact that the burn had nothing to do with growth, I don't know.
Fair.
I'll just do another set of high tension after this. Who cares? But if you know that the burn causes growth, man, it's a thing. It's like, if you know that the work you're doing is every hour you stay longer at work, you're getting paid overtime. It changes the dynamic of your coworkers. Like, hey man, you want to pack it in? You're like, I'm going to stay 2 more hours, bro. Like you're a security guard or something. They paying you real good for those 2 hours. If you were just getting paid the same, or if you were working for free at that point, yeah, I'm getting the fuck out of here. Let's go get a couple drinks. It changes the game if there's the upside and the knowledge of the mechanism. You know what I mean?
Yeah, man. No, I mean, that's like inspired a lot of my research. It's just like, I want to understand this to help apply it.
Yes.
And help others apply it so they don't waste their time.
Yes.
Right.
So imagine training a client. Let's say in a few years, let's pretend magically that we've confirmed pretty much like, yeah, okay, lactate and a bunch of other ions absolutely contribute to muscle growth. Imagine how that changes the dynamics of the personal training sphere. When, Betty's doing split squats, she's like, I can't do it anymore. Like, Betty, the pain you feel is literally the ions that make you grow. More reps, Betty. It's probably not nice to yell at women named Betty.
I don't know. She might like it. I don't know. I don't know. Is this a theoretical character, Betty, that is training,
She's there for
herself, right?
Yeah.
She's got to test it out. Maybe it would be motivating, and she would do some more reps and then keep coming back and get bigger and stronger. And
she racks the weight. She's like, don't ever mention science to me again. You're like, oh, Jesus, Betty. Sorry. Yes.
But time will tell.
Time will tell.
Yeah, but we need to do research on that in humans.
Yes.
Good longitudinal, well-controlled research.
Yes.
We don't have I don't want to overstate the literature on this, in humans.
But it's promising.
Promising, I would say. Promising.
Very promising.
Yeah.
Cody, it's been awesome having you here. You're the man. You know a ton of shit. If people want to learn more about what you do, if they want to learn from you, if they want to send you incessant DMs asking you technical questions, where can they find you?
Yeah. So I'm on Instagram, Dr. Cody Haun.
We'll link that on all the stuff.
Okay, cool, man.
Huge honor to have you here. Major thanks.
Dude.
We'll see you on the gram.
Hey, thank you so much for having me, man.
Of course.
And if I can say this, on the camera, you've been a big blessing in my life. You have. You've supported multiple of the studies that we talked about, if not actually through helping with funding, just moral support and like encouragement and questions and like topics, and like that's been very meaningful to me. So I really appreciate that. And it's not lost on me that you've been very supportive and consistently since I first met you, being an advocate for science and truth telling.
Sure.
And being objective.
Scott, did you hear that?
Like that's been my experience, and I appreciate that because it's inspired the way that I behave.
Cool. Thank you so much.
Yeah, man.
You have done nothing but impress the living shit out of me ever since I met you. So please continue your great work and keep impressing. And then eventually you'll have lots of YouTube money and everything will be fucking meaningless.
Okay.
See you guys next time.